Hello, my name is Kaiwa Joshua Magezi, and I'll be talking about some concepts in AI. So first and foremost, we're going to talk about hill climbing algorithm, and this is a simple optimization algorithm that iteratively moves towards the highest neighbor, basically. And the approach to this is for it's well, it's for this is it's easy to implement. It's often effective for simple problems, but the problem is that it can get stuck in a local optima. Now, this is a form of local search, and basically this one aims at comparing to the values that are next to a value, and whichever one is higher, it will go up, just like in hill climbing. Never goes down. We have, as you have seen, there's a problem of getting stuck in a local optima, so we can prevent this by using a simulated annealing method, which for it well, it's inspired by the annealing process in the metallurgy, which is the study of metals. And it's one of its benefits that it's less likely to get stuck in a local optima, and you can find a global optima here. The global optima is like the optimal answer, the best answer for a problem. And here you can compare both sides. You can decide to either go up or to go down. So it depends. You can either go up sometimes, depending on what causes you to reach the answer faster or better. And it's computationally expensive and requires a lot of tuning of parameters. That's one of its problems. We have genetic algorithms, and these ones are inspired by the process of natural selection, where different solutions are compared, and those that survive, uh, basically the process, are the ones that are taken. So the most optimal solutions become like survive longest, just like in evolution. And this can handle complex problems and can find multiple solutions because there are many like sort of offspring, uh, like which are solutions basically, and can be computationally expensive. It's hard to code such an algorithm and requires careful tuning of parameters. Then we have responsible AI and explainable AI. The definitions for these two are responsible AI ensures that AI systems are ethical, fair, and accountable. Then explainable makes decisions understandable to humans. Now, these two improve the algorithms previously uh, discussed in this way. Well, there is bias detection and mitigation, which basically is identifying to identify and address biases in data and algorithms. And there's also transparency, where AI makes the decision making process understandable. And we have accountability, where there is ensuring that there is a clear chain of responsibility for AI decisions. And next we have the adversarial search, and by its definition, we have this is a type of search algorithm where we have like game playing situations, and you need to make a decision where there are two adversaries, basically two opponents, and the goal here is to find the optimal strategy for a given game or problem. Now, there are some kinds of adversarial search, and one within those we have the Minimax algorithm. This is a recursive algorithm for decision making with two-player games, and this assumes that the players will both make optimal moves. So the pro is that it's simple to implement, and it's also effective for many games. But the cons are that it can be computationally expensive for complex games. For example, if you have like a chess game, it will be harder to implement that algorithm compared to like a tic-tac-toe game. Then we have the expect min-max algorithm, and this is an extension of a min-max algorithm for games with chance elements. So here you're just adding the element of chance, which means that the move that brings the highest probability of winning will be taken basically. And then we have the alpha beta pruning. This is a technique used to reduce the number of nodes that are explored in the minimax algorithm. And here, when the algorithm realizes that a certain branch cannot possibly create an outcome that it can take, it will not search that branch because it will be like a waste of time basically. Then adversarial machine learning is sort of connected to adversarial searching, and for this one, it's a subfield of machine learning that focuses on developing algorithms that play games against adversarial agents, against opposing agents. And the applications here are game AI and cybersecurity, among other competitive scenarios. And finally, we can see the uses of adversarial machine learning and adversarial search. So in here, we can see that adversarial machine learning often uses adversarial search techniques for training of models. Also, adversarial search algorithms can be used to evaluate the performance of adversarial machine learning models. Then finally, we can see that both fields focus on understanding and countering adversarial behavior in competitions. And that's it for today. Thank you so much for listening and watching this video.